Hello everybody, my name is ALEXY KHRABROV and I'm the founder and organizer of the Swift for TensorFlow meetup. This is the inaugural meetup, which actually is hosted by Google Developers Launchpad. And we're very excited to have the members of the Swift for TensorFlow team with us, Eugene Burmako and Suhan. Welcome guys. Tell us a little bit about yourself.
I think you should go first.
Okay. So as Alexei said, my name is Eugene, and currently I'm working at Google at the Swift for TensorFlow team. I joined Google in February this year, and before that, for about 7.5 years, I was doing Scala compiler tech. First at EPFL, this is the university where Scala got invented, and then at Twitter, which is probably the biggest Scala user in the world. That's it.
Yeah, I'm Alex. I work in the same team as Eugene. I've joined the team actually quite recently, about 3 months ago, but I've been working at Google for almost 2 years now. Before Google, I used to work at a startup running, making SQL run on GPUs, and yeah, that's my story so far.
So I want to add a little bit of the background that I also run a Scala meetup, and Eugene, as he said, is very well grounded in the Scala world, author of the macros and also RSC, the Twitter version of Scala, approach to Scala, right? And so we know Eugene as the champion of strongly typed programming. So I want to kind of ask you guys, what's your previous experience before Swift or TensorFlow with types, strongly typed languages? What's your feeling? Are they better than dynamic languages? Right? Like, if you can provide a little bit of a background for the viewers.
Yeah, I personally think dynamically typed languages should be banned, should be just by law. I don't have much background in using dynamic languages, so I actually kind of like them as well. It's just that most of my background has been C++ and tiny bit of Java at times, but that's the angle I come from. I'm very pragmatic when it comes to picking the languages, and I like static languages because you just get better support from compilers, from tools, from IDEs. So
is SQL a functional programming language?
SQL is declarative. SQL is its own thing.
Is it typed? What do you say?
Yeah, it depends. For example, you have SQLite, which isn't typed. Mm-hmm. So the columns are all they all have a specified affinity, but it doesn't have to be the type you declare. But yeah, usually SQL is statically typed.
Mm-hmm. And SQLite is like enormously popular, like it's everywhere, right? SQLite.
Yeah, it's a very popular implementation of SQL used by all sorts of applications. It's probably the most widespread SQL implementation right now.
Yeah, I didn't think about it as not type because like you never know what you get with SQL, right? Like you type, if that's correct, it probably will work. But if it's not, it depends on the implementation.
Yeah, it's definitely a loosely specified language, or at least that was my impression, that not everything is as precise as in the C++ standard, where you can have hours of fun trying to get the precise meaning of a certain statement in the standard. So
yes, because nobody fully implements the NC SQL standard, right?
Yeah.
So how about you, Eugene? What do you think about types?
Yeah, types are great. My work in the Scala ecosystem shaped my experience with types, so now I'm more of a moderate proponent of types rather than going all in. I think, having coded in Swift, I both missed the power of Scala, but also appreciated the fact that there are less food guns to use, so to speak. Mm-hmm. And in Scala, it's possible to write incredibly complicated programs, and while they allow to state very precise properties about applications, they also come with the host of issues like error messages, compilation times, and so it was refreshing to see a different approach to that thing. Specifically, what I like about Swift is protocols. So whereas in Scala we have to deal with implicits, basically design patterns that arose around that, with all the problems like error messages and stuff. In Swift, it's more seamless. So I think that types are great, and that it's good to look for balance between advanced types and something simpler like C, right? So I don't think that the more types the better. There has to be a balance.
Okay, and obviously it's super interesting. Like in my world, it's a huge breakthrough that Swift is adopted for TensorFlow by Google, right? Because we're preaching at Scala by the Bay and Scale by the Bay that Python should not be used. Like you should not entrust your machine learning and AI treasures to Python. It's like the most valuable data should not be handled by a dynamic blob of a language, which is slow at the same time, right? So basically, to me, it's a big paradox, and like there are many reasons, but you guys are kind of from my standpoint, you're like the beachhead of the advanced, like the typed force, right? Which can kind of finally do machine learning properly, but obviously, majority of data scientists do not know about this, right? So like if you can advocate for a language like Swift, typed language, performant language for machine learning, like what's the best things about it? If you're a data scientist who doesn't know about it, like how would you convince somebody to try Swift for TensorFlow instead of Python?
Well, the main advantage is the fact that you actually have a compiler, so you actually catch errors ahead of time. But more than that is just the world it opens. You can do things like ahead of time compilation more easily. So you'll get, at the very least, you could get more predictable performance if you don't have any sort of JIT approach involved. So if you could actually compile everything ahead of time. It also offers more opportunities to do some sort of more holistic optimizations on your model. So it can move code around, it can rewrite blocks of code, which in Python it's quite hard because there is no compiler there to actually cooperate. And I think those are the two main advantages. And also it's a fairly nice and well thought out language. So that would be the third.
To elaborate on more advantages for Swift or TensorFlow, not to say that the alternative approaches are inferior, but just to elaborate on the strong sides. We have a pretty good story with automatic differentiation, and I think it's uniquely interesting in statically typed languages in that it can produce errors statically at compile time. So when I just joined Google and learned about the project, this is one of the things that impressed me a lot. That you can just write those differentiable functions, and when you make a mistake, the compiler can tell you that this function is not differentiable because it calls another non-differentiable function, and that's the culprit. You cannot just call that thing. So it wouldn't just...
it's like serialization. Like everything should be serializable and everything should be differentiable.
Yeah, in a way. And so what I find pretty good here is that it's not like you get a runtime error with a kind of undefined message or something. You literally get like a compile time stack trace, which allows you to follow through the chain of code. And expanding on that, this is, I guess, a big benefit of statically typed languages, that you can have compile time checking.
So there is another aspect of it which is quite similar to the fact that you can actually have traces. The fact that the debugger actually, if you set up if some error happens, the debugger actually steps back through your function as it actually differentiates. So it's fully integrated. It just works.
I found that by a hard way that Swift REPL is LLDB kind of, because I tried to run it in WSL subsystem for Windows, and it didn't work in the WSL1, but then now it works in WSL2 because there was some stack call which was only implemented in WSL2, in the actual Linux. So that's I learned the hard way. Like I couldn't even launch Swift REPL, but now I can do it on Windows. So that's cool.
Nice.
So obviously it helps with the differentiation. There's the creator of Swift is actually working in your group, right? So I wonder if the proposals like this, right? Because I don't know much about the kind of how Swift is advancing. So it is created by Apple to make iOS development easier, right? And then Chris Leitner went to Google. So I wonder, how do you interact with? And now Swift team at Apple has folks like Konrad Malawski from the community who is doing reactive streams there. So like when the language evolves, do you guys talk? Because I know it's hard to know what Apple is doing. So I'm just curious, does it help? Can you, things like automatic differentiation, can they influence Swift language itself? Or how do you guys decide? Is the community process like SIPs and Scala? How is it advancing?
Right. So for those of you who know about Scala, there is a similar process in Swift. It's called Swift Evolution, and there is a similar committee, people who meet every now and then and discuss community proposals. It definitely helps to have Chris Leitner as our boss and the tech lead of the entire big effort. But I don't feel like we have special treatment. So we submit proposals just like the entire Swift community, and these proposals are discussed in those Swift Evolution meetings, and then notes are posted in a transparent way. So I believe this is a great thing because Swift community has many people who have many interests, and it is essential that we treat that with respect. If that makes sense.
Right, absolutely. So I'm curious, so you come from kind of hardcore back-end work. Compiler work is like the hardest, I would say, technical work in as far from UI as possible, right? And so Swift was used actually as a replacement, as a UI language, right? I think a lot of developers in Swift, in Scala world, we normally do not intersect closely. Scala.js is the closest as it comes, but it's not really has the adoption of Swift UI, right? So I'm very curious, and a lot of people who come to Swift UI, they come from JavaScript. So what's your observation? How do you, I'm very curious, because they have a very broad community, but it was anchored by Apple, right? And it looks to me like Swift quirks come from Objective-C, because they have to be compatible to it. It's like Scala has to be compatible with Java. These guys come from Objective-C, but they're also UI people. So what's your kind of impression so far? How is this community different from Scala community?
Good question. I don't think I have much insight here. So we've been focused a lot on Swift for TensorFlow, and I'm just learning about other aspects of Swift, so it would be premature to generalize.
Okay, we'll ask you a little bit later.
Well, I also have to do a bit of an educated guess here because I don't have that much background. But thinking about it, Objective-C is actually, a language which is somewhat like C++ in terms of level of abstraction. So people in that community and by extension in the Swift community are probably more accustomed to thinking about the actual performance of the code and whatnot, so reason about it. So I'm fairly optimistic that Swift could be suitable for both that kind of work and machine learning, because both are performance sensitive.
Yes.
So
I'm actually wondering, how do you interact with other parts? Like TensorFlow is big. So I talked to Rajat Monga for IBM Index and interviewed him actually, and I actually interviewed Francois Chalette. So for that, and so I kind of have a little bit of insight, and I understand the org is very big, and it's like Google people like to work there because it's the first major open source effort on Google. I think one of the, right, because a lot of stuff is internal. So how do you interact with Python side of TensorFlow? Are you like a little island, or do you cross-pollinate each other? I'm curious how the TensorFlow org, where you're there, and where is it going?
Well, we have interoperability with Python. We try to reuse as much of TensorFlow as possible. But I think we also kind of have to build our own path because we have those additional features like automatic differentiation, and most of those features, I'm not sure they actually translate well back into TensorFlow. So that's, I think it's an open question. I don't think we actually know exactly how this is going to go long term.
So you need to influence upstream.
Yeah, maybe, yes. Again, I think the fact that it's a static language and you can do so many tricks which don't necessarily apply to a Python framework will have some sort of an impact on how this happens.
And so what is the, you're going to talk about machine learning intermediate representation, MLIR. And just accidentally, I opened my Twitter waiting for the meetup to open, and I saw Sundar Pichai tweeting about MLIR right now. So nice. Is he helping us? Is he aware? But like, obviously he knows, and it's an important thing for Google as a whole. So I'm wondering, right, are you guys on like the cutting edge, and like what's the place of MLIR in TensorFlow? Or because, I mean, TensorFlow is just one way to do machine learning, right? Like, machine learning is bigger than TensorFlow, right? Like, it can be anything. It can be, right? So I'm just curious, like, is it, like, it's a structure, it's a project for TensorFlow, a Swift, or can it be something bigger? Like, how do you see it in the organization?
Yeah, so MLIR is a good point. And it shows that, you know, our project and TensorFlow, basically, well, we're called Swift TensorFlow, so we're part of TensorFlow, right? We have the shared future, and initiatives like MLIR, they benefit both of us. So concretely, with MLIR itself, as the announcement says, it started within TensorFlow, but it is bigger than just TensorFlow, and I believe personally that it could be applicable to other machine learning systems, and lots of hardware vendors they're actually already on board. Again, the announcement lists some very prominent names.
Cool. So we're very excited. You know, thanks for sharing all the insights. We're looking for the main talk, and thanks for starting this meetup with us.
Nice. Thank you very much for organizing.
Okay, thanks.